Hi friends, this is the follow-up to the tutorial I made with Kat Evans yesterday on using the QC app for ocean glider data. My name's Dan Kelly. So what I'm addressing in this one is an error that I stated in the previous tutorial, and I was thinking that this slider here called hide after power on did not work, and I think that it does work. So I'm going to demonstrate that here for you just today. So the graph is showing you, it's Yo 305, and if you look at the line just above the plot, you can see it says Yo 305. This just sort of helps you to see how this works. I'm color coding pressure as a function of time. I'm color coding it by the navigation state, so-called nav state. And so the way this worked is that the glider was near the surface. We made some measurements with the CTD, and then the CTD was turned off as the glider descended to about 100 meters. This is a continental shelf off Nova Scotia. And then the nav state changed to inflecting upwards. Look at the key here. And the glider started going upwards, and then the nav state was changed into ascending. Okay, so that's pressure as a function of time. Now I'm going to show you salinity as a function of time. The initial salinities are low. In this domain, salinities low near the ocean surface and high near the ocean bottom. And okay, and now here we are. This is during the ascent phase. And you can see that the salinity here is low. This is spurious. It's low for a little while, and then it becomes high, and then it descends. Well, it's low for a little while simply because it's averaging where the mouse is now. It's averaging data from the previous collection. The previous collection had a low salinity. So it's like it's just adjusting here. It's doing this averaging, which is, I guess, intended to get rid of noise, but for a CTD that's turning on and off, it's problematic. And that's what this hide after power on is meant to be helping with. So I'm going to slide it from 0 seconds to something in the middle, 37 seconds. You'll see the graph will update in a second. Okay, you see the graph updated. And now what we have is, as we move up through the water column, we're at the bottom of the water column here, as we move up through the water column, salinity increases basically monotonically. This is the correct behavior. And I'm going to show you, just to double check that, I'll show you a density profile. And this density profile looks reasonable. And in fact, the colors here are showing that the previous downward sampled data have about the same density as the upward sampled data during this portion here. And I'm going to change this hide after power on back to 0. In other words, we're not going to do that hide after power on correction. What you can see now is completely spurious, in which the deepest waters have a lower density than the waters above them. And basically, this is aphysical. This could only happen if you had strong convection, or we're about to get strong convection, which is simply not the case. So we learned two things from this. One, I was wrong in the last video. This slide after power on does work. And the other one is that it seems as though for this particular data set, that you have to omit something like maybe 20, 30 seconds of data during the ascent. I don't want you to think that that number is fixed in stone. I think it has to do with just all the settings being used and the properties of the water column and so forth. This is the end of the video. Thanks for watching, and we'll talk to you again soon.